Assalamualaikum and a very good day to Professor MADYA Surveyor Dr. Muhammad SALIM bin NASIR. This is the group project which is Interpersonal skill for the subject Introduction to Numerical Analysis MAT 575 for group CDCS 2494B. Here are the team members. The first one is me myself, Muhammad Aqib bin MAAROF, and the other one is Luqman Haqiem bin Muhammad SHAFIE. Next is the table of contents, and we have the introduction, objectives, methodology, implementation, result and discussion, and conclusion. So we will continue with the introduction. First and foremost is the trapezoidal rule, with the purpose of the numerical method for approximating definite integrals, with the application for useful when functions are not expressible in elementary forms, and also applied when the data is tabulated, form, or in the numerical solutions are preferred. There is a given formula there, and the accuracy increases with more subintervals. Next is the discrete least square method. The purpose of the method fits the best curve to the data by minimizing residuals, which are the differences between observed and predicted values. Next, the application for the method is ideal for experimental data with noise or errors, and also common in engineering and scientific analysis. Next is the shape of the Taman Negara. Why we chose that is because the trapezoidal rule is a map-based application for the purpose of approximate the areas and volumes of irregular regions using the satellite imagery from the Google Maps. So the uses of the application are to calculate the total area of Taman Negara using the latitude and longitude boundaries. Next is the discrete least square method for the map analysis. The purpose of this discrete least square method is to fit curves and trends to complex boundaries or elevation data. The uses is to create a smooth boundary model for Taman Negara using the irregular data points from the Google Maps given. Next, we are going to discuss about the objective. So the first objective is to investigate the numerical techniques, which is to focus on the trapezoidal rule for calculating areas and also the use of Google Maps view of Taman Negara as the case study. Next is to calculate the area of the irregular forms, which are split into the irregular shape of Taman Negara into small parts, and also approximate each part as a trapezium for areas estimation. And also the last objective is to explore the discrete least square method of the simulate uneven boundaries of the part and to smooth and analyze the observational data for accuracy. So the goal here is to provide insights into applying the numerical methods to the real-world geographical analysis. So I am going to explain a little bit on the methodology that we use. So the method that we use is the data extraction, which is obtain the boundary coordinates xi and yi of the Taman Negara from Google Maps. So on the trapezoidal rule for the area calculation is to divide the boundary into vertical strips and treat the area under each strip as a trapezoid using the formula that was given. Next, we're going to use the discrete least square method, where it's fit a mathematical function, for example given a polynomial or linear curve, to the boundary data and minimize the residual between the observed points and the fitted curve function x using normal equations. And last but not least, the combination approach, where the least square method ensures an accurate representation of the park's boundary, while the trapezoidal rule provides a reliable estimation of the park's total area. This integrates the numerical method techniques to estimate the Taman Negara of the shape effectively.
Assalamualaikum, my name is Luqman Haqiem bin Muhammad SHAFIE and my ID is 2033397737 from CDCS 2494B. I'll be presenting on the implementation, result and discussions, and also conclusions. Next, implementation of mathematical methods for analyzing functions. First, to obtain each fx1, fx2, fx3, and fx4, we find the function using the discrete least square method. In this method, we determine the degree m of the polynomial, which in this case is 2. Then we find the total number of points, and it's 4, and calculate the values for all the elements in the matrix form 3 by 3. Using the summations of these values, we construct 3 by 3 matrix. Next, we apply Cramer's rules, the crucial second step, to find a node, a1 and a2. Using the determinant, we calculate a node, a1 and a2 by dividing each determinant by determinant a. With these values, we write the general expression of the polynomial. Finally, using the trapezoidal rule, we identify the interval AB. The next step is to identify the step size or the numbers of subintervals, n is equals to 7. We calculate h by subtracting a from b and dividing by n, giving h 0.5. By performing the table calculations, we determine the values of x, y, the coefficients, and the product of the coefficient with y. The coefficients for the trapezoidal rule are 1, 2, 2, until the last one is 1. Lastly, to get the final result, we multiply h over 2 with summation of the product of the coefficients and y. Then we got the fx1 is 26.9740 units square. Next is the result and the discussions. These are the results obtained by applying the trapezoidal rule to estimate the areas under fx1, fx2, fx3, and fx4. These corresponding examples illustrate the computed areas and coefficient used. The precision of the trapezoidal rule depends on the continuity of the functions and the quantity of the interval used. An increased number of intervals, smaller h, often yields a more precise estimate. Since these are not the exact area of Taman Negara, so we have to calculate just the following numbers, which we have to use subtraction of areas. First, subtract the area under FX1, which is 26.9740, with the area FX3, 10.6897. Second, subtract the area under FX2, which is 26.8049, with the area under FX4, 13.5630, and add both answer and you will get the area of Taman Negara, which is 29.5262 units square. Lastly, in conclusions, in order to estimate the area of Taman Negara, we successfully used the discrete least square approach and the trapezoidal rule in accordance with the goals and objectives stated in the study. We fitted an accurate mathematical model to the park's uneven shape using the least square method after obtaining boundary data from our Google Maps view. After that, we adjusted the step size for better precision and used the trapezoidal rule to determine the area under the fitted curve. Using these techniques, we calculated the final area of Taman Negara, which came up to be 29.5262 square units. This outcome shows how well numerical techniques like the trapezoidal rule and least squares can be combined to precisely estimate the areas of complicated shapes. That's all from us. Thank you for watching.